Hi, everyone. Sorry for the 10 minutes delay. Actually, we were waiting for people to join from the last session. So today I will be presenting, first of all, my name is Mehdi Belmekki. I'm Alfresco Principal Consultant. I'll be presenting today Alfresco Geo-Dispersed clusters. So first of all, I will start by introducing myself. So I joined Alfresco since 3 years, but I have 7 years experience on the product since early versions, version 1. I started with the Alfresco community and got awarded in 2008 as a community contributor, and then certified recognized developer with an Alfresco partner in 2010, then certified administrator and engineer with Alfresco Limited, and then employee of the quarter during this year. So my areas of expertise are repository services, solar tuning. I had the last summit talk about solar tunings and troubleshooting and performance improvements. Share extensibility, audit API subsystem, and authentication subsystem, and cluster architectures. So the agenda for today. So first of all, I will be discussing geo-dispersed clusters, why do we need it, what it is, and in general, why do we need it. Then after that, I will be talking about Alfresco cluster components, what we should take into consideration when we are designing a geo-distributed cluster of Alfresco. What are the available options? So we can have active, passive, hot, standby, warm, standby, etc. I'll mix those in a simple sample cluster that I will share with you that I've been able to build between London and Atlanta, which is actually up and running. And then I will share with you my current R&D pipeline, so what is the next steps, and we'll answer your questions at the end. So the talk objectives actually today, the main objective is to explain you the geo-dispersed architecture, the challenges you can face while deploying such architecture with Alfresco, clarify the needs and prerequisites to success such deployment, either the things that you should keep in mind while designing your database or storage layer or caching, and all taking into consideration all the Alfresco cluster main components. I'll share with you various the architectures that can be deployed and provide the sample implementation, and share with you my lesson learned during this implementation. So first of all, I'll start by discussing the geo-dispersed clusters. What is a geo-dispersed cluster and what is the need? So as everyone knows, the knowledge cycle inside the company starts from data. A data is a number, is whatever that is a value that you cannot use unless you interpret it to extract an information. This information is in general grouped into a semantic context that is stored into a content. So content actually holds your documents, holds many information and many data. And then this content is pushed to human actions that actually extract new data, and so on. This is how we build knowledge inside the company. So when time is precious, knowledge is priceless. So if you lose your data, it's okay, you can rebuild it. You can automatize actually, or get a new database, or get people to fill in your database. But when you lose your content, you lose knowledge. And if you lose knowledge, it's nearly impossible to build it again. So this is the first requirement of geo-dispersed architectures, is the availability. So people from the beginning, actually, we always think on having a second backup. So if in power, if a fuse blows, let's have a second fuse. If a RAID disk blows, or crashes, let's have a second RAID disk with all the content inside. Then we moved, since our content is hosted on network, so if the root or the network is down, let's have a second NIC root or a second cluster on network. And if a server down, let's have another server. This is what we are talking about, the clusters. And if a whole data center actually crashed, let's have another data center somewhere else to move the computation to, or to get the backup from, and to restore the data. There is a second need that actually raised since the NSA Snowden case that everyone knows, is that sovereignty against the information and documents. Where is the documents are stored? So since the Snowden case, actually, governments start claiming and requiring from software vendors or from their organization to take care about where is the information is stored. So, for example, the European Union actually requires that requires the rights of data hosted or originated within the borders in the European Union. USA claims actually the rights over data even if hosted in foreign countries, like the affair with Microsoft and the access to Ireland data centers. Australia has no Bill of Rights at all, so if you store your data in Australia, anyone can access it with no problem, with no pursuit if done. So now governments actually requires that their citizens' data remain within the borders, and they apply restrictions so who has access to such content. So the IT mission actually drifts from delivering the right information to the right person in the right time to ask the question from and to the right location. So the definition of geo-dispersed cluster, as everyone knows, is that when you have a cluster, that each node or a couple or group of nodes are distributed into different continents or different cities or different countries. These nodes communicate each to others in order to ensure data consistency and act as a single system when the system is distributed, for example, or just to provide high availability and redundancy where the system is replicated over 2 data centers. We define 2 main families. So as I said, either your content is replicated between 2 clusters between New York and Paris. So if one of these clusters is down, the other one is still able to deliver the services to your end users because data is 100% replicated between 2 data centers. Or you have another family where your content and your data is actually sharded between different cluster nodes. So in general, you have a central server node that keeps and maintain the quorum between and maintain in sync all your cluster nodes over different geographic locations. The advantage of such deployment is that it provides an easy to implement disaster recovery with this continuity plan. It's a simple high availability model, and it can, for example, if you are managing big data, and you have your end users or your customers accessing the data from India, and they want to download big files from Atlanta, it will take a while. So we would like to get this data close to Indian or the opposite, vice versa. So it allows as well to horizontal scalability. So you add more servers, you add, the more power you can get. It cost efficiency as it is cheaper to get 10 a bunch of commodity servers costs always less than 1 supercomputer that you can host somewhere. And it allows to distribute the workload and to have less work by server, and it solves the data sovereignty problem, especially where for organizations that are actually multinational and need to collaborate on content and share the content between different governments that have different laws. But this is not with no cost, so there are many challenges. First, how to make sure that the site is up and running. Can we rely on network? If we rely on a ping or stuff like this and there is a problem in the network, can we say that the cluster is down? Maybe it is not. We have just a problem in the network. Can we be sure that we won't have a split brain scenario and that each cluster or each data center will have its own data and not in sync with the other? Can we manage the failover and how we can do it, and how we can be sure that, as I said, data consistency and fault tolerance, and how we can go over network bandwidth limitation? Because as everyone knows, we have a map of tubes that actually connect each continent to another one, and you cannot go over some limitations in bandwidth. So we cannot deploy a cluster, for example, between Russia and Canada, because there is only one link that the bandwidth limitations and all the stuff will make it impossible. Now I'll be talking about Alfresco cluster components. So what you should take into consideration when designing your cluster. So we have 6 main components. You have the application server, which can be Tomcat, GBoss, WebSphere, or any other application server. You have Hazelcast caches. You have your database layer, your content storage, your indexes, and the hardware itself. Regarding, I'll start first by the application server. It's not covered in this talk as it's not critical, since the clustering mechanism in the application servers actually allows only to share the session, and it handles replicate the current user session between different clusters. So it is not impacted by the geographical location of the cluster, neither by the bandwidth between 2 different servers. And in the worst case, if it is not set up at all, the user will be only prompted to log in again in Alfresco, for example, that's all. So it's not interesting. The cache, in fact, is very important, as if the caches are not in sync between 2 cluster nodes, for example, active Alfrescos, we won't be able to see any changes from one share and the other one, and we'll have a split brain scenario between both instances. So Hazelcast actually provides out-of-the-box support for 1 replication even and 1 deployment clusters. You'll need to take care about the TCP IP timeouts and increase it, because the default values that are provided with the framework are used for local area network, not wide area networks. And in Alfresco, you'll need to increase your heartbeat timeout to, by default, it's 15, but it depends on the bandwidth. You will need to increase it to 30 or 1 minute, so we do not drop a cluster node just because there is a problem on network, or networks became slow. So this is how it looks like, the Hazelcast WAN configuration. So all you need is to define your location with the servers inside in each active cluster. So the passive clusters, we can avoid putting this configuration on it. So when you define your 1 replication reference, you need to add it to each map that you want to replicate over your geo-dispersed clusters. I'll go now to talk about database clustering in geographically based cluster. So there are many layers where we can set up this redundancy or this replication or sharding. So first, we can do it on the JDBC layer using for example, JDBC, which is a framework in the application of JDBC that actually can connect to many databases. So you have nothing to change in the application layer or stuff like this, just to provide your cluster, your database IPs and configuration to the JDBC, and the JDBC actually will replicate your transactions in many databases at the same time. So the JDBC supports out of the box any database accessible via JDBC, so MySQL, Postgres, Oracle, and all the stuff like this. It's high tolerant to faults and network failures, and it provides GMX interface and a lot of other features. We can act in the access layer and add the proxy application that actually will manage a form of database service, like Tungsten, for example, which run a benchmark on different products, and this is one of the best I want to share with you, which is a drop-in replacement for native MySQL replication. So you don't need to, if you use Tungsten, you don't need to use MySQL replication anymore, as it is slow, etc. It provides high performance in terms of replication because it is multi-threaded and thread safe, etc. It's flexible in terms of topologies, as it can be built or set up on top of heterogeneous databases, not only a form of MySQL. The form can be MySQL with Oracle, with Postgres, and stuff like this. And Tungsten actually will manage the replication between the different databases. It provides the filters and routing mechanisms. So the filters can be used to actually shard your database between 2 different servers, or to replicate your database between 2 or many other databases in one environment. The routing methods can be used actually to either split the load in your farm, so you have all the reads going to one server, all the writes going to one server, It has four methods in general. So the smart scale, actually, it is dynamic splitting of the load based on the database load. Actually, when you run a query, Tungsten will redirect it to the node with the less charge. You can direct the reads, as I said, to a node and direct the writes to another node. You can actually route your queries based on a host or a port or SQL based. So all the selects go to the node 1 and all the update go to node 3, all the inserts go to node 4, etc. So this is kind of what Tungsten can allow as architecture in terms of database form. So we can have one master writes into many slaves, heterogeneous databases writes into each other, or providing the same form of database. We can have many master database writing into the same slave. We can have many database replication in each other or in a star topology. There is another application that provides a server layer replication and server layer clustering, which is Galera. It is a true multi-master, so you can deploy as many masters as you need. It takes take load and sync replication task. There is no slave lag, no integrity issues, automatic failover. You can add a new node and then Galera actually will split or will replicate your data in it. No need to add configuration stuff like this, but it's still a MySQL plugin and it's a MySQL patch. So you can use MySQL Cluster, for example, as well, which provides MySQL Cluster Manager. It allows horizontal scalability, so more database node that you add, the more storage you have, and you can actually scale vertically as well by adding more capacity to each database node and having more performances. The advantage with MySQL Cluster is provide a native support for multi-site clusters with geo-replication. MySQL Cluster can shard your database content on a transparent way between different database servers. It can be row-based or column-based, and it's transparently managed by MySQL Cluster. We can set up the replication on the block. It can be a block-based, which is the low layer using DRDB, GFS, which is similar to SunHA, but actually it cannot support more than 2 nodes, and it has a big impact on performances. So just to summarize the success case for choosing which technology you would need to use on your geo-replication deployment for your database layer, you'll need to use the right replication technology and configure it properly. You should choose the row-based replication, not column or schema-based. You'll need to take care about preventing collision in inserts, and you need to take care about the network latency that shouldn't be high, and use local database when possible. I will share with you later that because I've done the test with a database hosted in internet, and the cluster just fails. So when you will be using the database, just use the local when it is possible. Otherwise, you will need to use Tungsten or any other replication application that can manage your cluster. So the file system layer, we have many applications that can take care of this. As everyone knows, Hadoop distributed file system, GlusterFS, ExtremeFS, Lustre, Safe, and FS3. So Hadoop distributed file system actually provides a lot of advantage, which is scalable, cost efficient, used by Facebook, Google, many other big applications for big data analysis. It is good scale and fast for large data, but it is not efficient with small files. So if you are managing just files with 2 megabits or stuff like this, and the size, it might slow down more than provide any improvement. And till the latest version, it has a name node as a single point of failure. So if you lose the name node, your whole cluster is not working anymore. The last version actually can cluster even the name node, but it's still in development. GlusterFS actually provides the same advantage, plus that it is scalable with small data. And it actually, GlusterFS is based on bricks, which are shards of your file system that are managed by the same application and providing a single entry point, which is a mount point, that is managed by, virtualized by GlusterFS, that takes care later on replicating between two different file systems, shard your content, etc. I will show you the different architectures in the next slides. So GlusterFS actually allows to scale out on performances by adding more servers, or scale on capacity by adding more capacity on each server, because Gluster actually will use all the servers to either host your content sharded between two different volumes, replicate it between two different bricks, which can, each brick can be, or it is actually a standalone server. It allows you to strip your volume into many bricks, not only two, and you can even combine one or two, so you can have distributed, replicated on distributed, stripped, or replicated, stripped bricks, etc. So regarding the index clustering and network optimization that you can or you need to implement to success your deployment. So the indexes, first, there is the challenges that they are constantly changing the state. So if you do for example, if you just host your indexes locally with a high bandwidth, but still on local area network and LAN, you will see that actually the performance of your global system decreases. It's always a bad practice to have the indexes located outside of solar machine or Lucene machine. The solution, for example, since Alfresco 4.2, we provide a no-index subsystem that redirects your database search to search service. So you will have only to take care about the database layer clustering, which is in general fast and reliable, or you can maintain your own, each location should have its own solar server deployed, or switch back to Lucene to rebuild back a local index. But we cannot deploy Geo-Dispersed or either replicated or sharded solar indexes or Lucene indexes. Regarding the network, we can use NIC teaming, so have more than one network adapter and use it in order to improve the network bandwidth, or use multiple network routes. So when we have a route broken, we can still use another route using multiple switch, and it provides a high fault tolerance. We can use one accelerator, which actually compress the network packets and send only the data. So it optimizes content by sending only the difference. And there are a lot of optimizations implemented on the one replicators on the application layer. So NFS or CEFS, etc. It's application-aware devices. So now I'll be talking about the geo-clustering architecture. So we can either use active passive, which is a supported Alfresco disaster recovery business continuity architecture, as the active is not supported right now. So the decision on the RTO and RPO will impact on what backup restore strategy you will need to use. I will detail this in the next slide. It offers a full redundancy, redundant instance. So if you have one instance down, you can just go and start your second instance and your services are back. So either you can use the cold standby. So the second node is available but is powered off till the first node is down, and then you move your computation to the second one. You restore your data, you start the services, and then you switch with the load balancer to your new location. The recovery time for this procedure is a few hours. You can use a warm standby, so data is regularly mirrored to the passive or the second node. Maybe it can be daily based, hourly based, or weekly based. In case of failure, you just start the services and you switch back to your second node. You can have hot standby, so data is mirrored in a real time between both active and passive server, and services are already started, so the load balancer needs just to switch to the secondary node in order to recover. So the recover time is of few seconds. You can use active-active with replicated architecture. So you have the data is replicated between both nodes, and it's multi-master Alfresco deployment. So both nodes are active and are receiving the requests from end users and replicating to each other on the database layer and the file system layer. So there is no recovery time, because actually if one node is down, the load balancer will just redirect all the queries to the second one. Or you can use active distributed, means that you will have the half of your data in one server and the other half on the second server. And this can be done using Tungsten and GlusterFS, for example, which can distribute the load and shard your database between two different locations. And GlusterFS can do the same for your file system. So in the next slide, I will be sharing with you what I've been able to deploy and what is currently stable cluster that I've been able to configure. So first, I had a failed test when I tried to set up a cluster between Atlanta, London, and Paris, when I actually have just hosted the database and the file system in Paris, and configured Atlanta cluster and London as a cluster, as Alfresco cluster. So what happened is that my system starts, instead of taking 5 minutes, it starts in 30 minutes, especially the first start when actually the cluster needs to create the database schema and create the content and all the stuff. So it takes me 30 seconds, even if I have a fast connection in the fast network in Paris. So then I moved to a second architecture where I deployed local file system and local database, and I took care of getting the replication between MySQL nodes, which was the native replication. I configured the Hazelcast one. I enabled the Hazelcast configuration for one area, and configured GlusterFS server cluster between the two geographic locations for replicating content between US brick and the EMEA brick. What is the advantage of this deployment is that you can even shard your content. So keep US content in the USA, but it will be available to European end users as well as access if requested, and the opposite and vice versa. You can keep your EMEA content in EMEA, but US guys can access it on demand. The problem with this architecture it cannot go further than only 2 nodes, because actually multi-master replication on MySQL layer cannot support more than 2 nodes. You cannot have multi-master for 3 nodes or stuff like this. So, and it's still, if we have any failure between both MySQL nodes, we'll have the split brain scenario. So we'll need just to dump again the database and resync the whole database before starting again. And this cost a lot of time. So the second move was to deploy this architecture. So I've added Tungsten on top of MySQL. So I have Tungsten cluster server deployed geographically between Atlanta and London. The same for GlusterFS. So there is either replication. I've deployed replication, but you can do sharding as well for your database between both MySQLs, and it's actually optimized. So London Alfresco, for example, will have, if it goes through GlusterFS, it first go to the EMEA bricks. So we don't have to deal with the network latency unless we need a content which is in the USA. And the opposite, again, from Atlanta to London. And this happens as well in the Tungsten layer, because it redirects your queries to the local database, which is deployed locally by setting affinity. So that's what I've been able to deploy right now. What I have in the R&D pipeline, so currently I'm working on deploying a 3rd node in Sydney. I will keep the same technology, so Tungsten and the GlusterFS, and we'll test it on such deployment. But right now it is stable on between Atlanta and London. Any changes on share or caches are well handled, and databases are well replicated. Even if there is a failure, Tungsten actually have a global ID transaction, so it just replay again the same transactions on the new joining node. So That's all for today. So if you have any question, I'd be happy to. Yeah. Okay. Okay.
Maybe if you can show us the latest schema one more time. Yeah.
This one.
Yeah. When someone in the US accesses content which is in Europe, is there some caching, or every time it has to download it from the...
No, right now what I've deployed is out of the box Alfresco, so I didn't implement any caching. But yes, we can have a cache, or actually we can even configure Alfresco. So when the document is requested the first time, we can copy it to the new location. So there is only the first time request, which will be slow, and then any other person or end user that will request the content will get it faster because it will be deployed locally. And this layer is managed by Gluster. I mean, it's not even Alfresco who will set the affinity or which server to tackle. It is Gluster. That's why it is 100% transparent to Alfresco. But yes, we can set up in Gluster, say, when you get the first time the content from another break, please copy it to the local break you have. And this is one of the advantages of Glusters. So, any other question?
Yeah, you mentioned on your slide earlier on MySQL cluster.
Yeah.
Is that the product, MySQL cluster?
Yeah, exactly.
Okay.
That's the product, and it's natively support Geo-Dispersed nodes. So yeah.
So because I've spoken to MySQL because we're considering using MySQL cluster as the product, and they've asked us to clarify with Alfresco that Alfresco supports MySQL cluster.
We do support it, actually, but we do not support the sharding of the databases. So if any problem happens, we will try to reproduce it on a normal cluster with replicated content directly on MySQL without clustering. But otherwise, it's transparent for Alfresco if you have a consistent database, which is a single entry for consistent database, which is the MySQL cluster IP, for example. It's transparent for Alfresco, whatever you use behind the scene. But if you have any issue later with the product, we'll try to reproduce it using a MySQL instance, not MySQL cluster.
Okay, because obviously it's a true active architecture, isn't it? MySQL cluster. Yeah. So with the intent, you have to have intent to write and things like that, don't you? To many active nodes. I wondered how Alfresco does that.
No, Alfresco doesn't take care about writing, about replicating the transaction and the different node. It will just send the transaction to MySQL cluster, and MySQL cluster should take care of the other events of the whole process.
Cheers.
Okay. Any other question? Yeah. Okay. Thank you.
Just in terms of the indexing component, I don't see Solar there. Yeah. So one of the things that I can see potentially could be a problem is that if you've got replication or updates between the databases and the two databases in geographically disparate areas or regions, they're not in sync. What is the impact then from a Solar perspective, for example, where it's polling the repository for its updates?
Okay, what is the risk, for example, is that your transaction actually, it's already on the database while the content is still replicating between the different locations. So Solar will ask for the content, will not get it. If you are using active passive, this can work. You can change, for example, the Solar tracking time to minutes or 15 minutes instead of 15 seconds. And then you can be sure that the content is available on the new location before starting the indexing. But
so basically you're saying that you have to raise the threshold to the point where the worst case scenario that you would hit, otherwise you'd have a situation where it's out of sync and you have to go through and correct it manually.
Exactly, because you cannot just shard the index. As I said, if you do it locally in your local network, you will have 50% or more the performance decreasing on Alfresco or in the server itself, not even Alfresco, on Solar layer, on Solar application. So if you put it, this is if you put it on a LAN. You can imagine if you put it on internet, or you can host it on Amazon or stuff like this, you will just kill the server.
Okay. Cool, thanks.
Okay. Any other question? Okay. Thank you. So, so if you have any question later that you want to share with me, you can just drop me an email, mehdi.belmekki@alfresco.com, or drop an email to consulting@alfresco.com, and we'll be happy to provide an answer or provide our recommendations for. So thanks for your attention, and I wish you a pleasant end of day.